This is what I'm trying to avoid is the minutia of the Einstein Newtonian and the math period. I'm talking about the friendships. I'm talking about the way it's set up and the way we are looking at the friendships on the plate, whatever. Okay. The point is, it doesn't matter what they calibrated. Okay. They didn't recalibrate it every time they set it up or when they changed directions. Okay. They set it up the same way as best they could over and over and over. And Dayton Miller did it like millions of times. And no matter how they did it, they kept getting this same null result. Okay. So even if what you're saying, you're trying to lose us in the minutia of all the mathematics, the math don't matter. This pattern didn't change. They got the same fringe every time they did it. So even if they had it calibrated wrong, it would still show a change when the Earth was speeding up or slowing down. It would have showed that change easily. Like it was enough to show that.
No, Bri, the thing you're not getting is, right, so say, let's remove the minutia. All right, let's say I have a detector and I calibrate my detector so that it can only measure nanometers larger than 750 nanometers. I set that as the 0 point, right? So I have all these other signals that are 500 nanometers, 400 nanometers, 200 nanometers, that my detector is already calibrated way above that. So it's not going to detect those signals. It can only detect the ones above the baseline. That this isn't minutia.
Bro, that has nothing to do with if they just have an instrument
That's
just sitting.
That's exactly what it has to do with it, Brian. It's what they did.
You said you could have put the minutia and you went further into the weeds, bro. Listen, if they have a device just sitting there doing nothing at all, and they do it at different times a year, they haven't recalibrated, they haven't added or subtracted any light. They got the same.
They have the equations in their paper. Brian, they have the equations in their paper for the velocity, the calibration velocity. They were using the Newtonian orbital velocity is what they were using as the calibration point.
Why can't you just talk about the physical experiment? Why do you have to talk about the
that
light?
Is the physical experiment.
So what I'm saying is if an instrument is just sitting there, Jay, and all year long, okay, all year long, never changes, okay? So why did the pattern, this friendship never change? They never even mess with the device at all. So don't talk about Newtonian, Einsteinian, nanometers, just the pattern on that they measured. Talk about that. Why didn't it change?
That's not the experiment that they did. It's clear in the paper. They tell you what the calibration velocity or the calculation for determining the calibration velocity. And it was the Newtonian orbital velocity. It's what they were using as the calibration velocity.
That's why I asked you to avoid
for any measurement, Brian, you have to set a 0 point. They set their 0 point at this large velocity.
Be hard to talk to you, bro. I'm trying to get you back on point, bro. You keep going off and on about calibration. I'm talking about once it's set up and it's just sitting there. You're saying they didn't do this. Maybe not. They didn't write about it in that paper, but they most certainly did do this. This was proven that the instrument just sitting there dude left it running one time for 3 years. In the same place, okay? He didn't touch it.
Matter
for 3 years. It never changed, Jay. Jay, it never changed.
It doesn't matter, Brian. If it's calibrated at the Newtonian orbital velocity, they could leave it there indefinitely. It's never going to pick up a measurement.
That is so, bro.
How do you prove that they calibrated it? How do you prove they did that?
They wrote it in their paper. In their procedure, they outlined how they calibrated the instrument.
So that's how we know. Wait, so when they calibrated it, that's how they know there was a Lorentz contraction and the whole universe, like, as one big reference frame, like, contracted. So the ruler contracted, so we couldn't measure it.
No, their idea was that they needed to get rid of the Newtonian orbital velocity. They needed to set that as the 0 point so they can measure the ether velocity, right? So they could pick up a signal from the ether. They had to remove all the other signals they thought were there so they could pick up the ether signal. And they outlined that very clearly in all of the papers that they published.
And they did detect motion. They did detect motion through the ether, but it wasn't enough, right?
Shout out to the ether.
The results they report are within just standard instrument fluctuations. So if you have a ruler that has a plus or minus 0.1 centimeter, error bar, right? Their measurements were within that plus or minus 0.1 centimeter.
Dilate time and contract the instrument, bro. That's after. That is nonsensical. That's why I'm trying to keep this argument. If I have an interferometer on a train track and I've got this train just doing a little elliptical circle, okay, where it's speeding up and slowing down and it's not perfectly circular, okay, and I put that device on there, no matter how I calibrate it, Jay, it's going to change, okay? Now, how I calibrate it, when it speeds up and slows down, it's going to detect that displacement, period. That's what the device is made to do. That's what it does. It does it with ridiculous accuracy. Your brain won't let you out of the maneuver.
That's not true, though. That's not correct.
You don't think it's
can calibrate. You can calibrate an airplane's motion out of calibration. Just means you're setting the 0 point of the graph of the data that you're getting at a specific value. You can measure what the value of the shift is for airplane motions, calibrate the device to that value, and not pick up airplane motions because you've zeroed it out.
Dynamic calibration. How are they doing dynamic calibration? In other words, I don't care how they calibrate this thing. If I calibrate my scale to -2, okay, if I put a different weight on there, it doesn't matter. If I put a 100-pound weight on there and it keeps saying 98, 98, 98, okay, then if I change the weight and put a 102-pound thing on there, it's going to say 100, okay? There's no such thing as that I know of, dynamic calibration in interferometers. If you kind of just invented the term. What I'm saying is that if there's a change, the device is made to detect that change in speed, and it's made. That's what the whole damn device is made for, bro.
Brian.
So you're saying that it's not going to detect change? That's what it's made to detect.
It's not that simple, right? They had postulations about the ether. Their goal was to measure signals from the ether and these hypotheses they had about it, right? So the first thing they had to do was zero out any other signal they thought could possibly be there, so they could just zero in on the signal from the ether. So these Newtonian orbital accelerations that you're trying to bring up were already considered in their calibration, because that's not what they were measuring. They were trying to measure a distinct signal from the ether.
I know that there's no motion at all. Okay, I know that. So I'm trying to explain this to you. Is this the way you learn shit? You just argue and throw in what you do know, and this is how you learn? People have actually read up on.
Okay, if you read devices,
hold on, you're arguing the basics that the interferometer detects displacement, period, down to the nanometer. This thing was, even way back then, it was so over engineered. It was 10 times sensitive enough to detect this motion, and you keep talking about Einsteinian, Newtonian. I'm trying to get you to focus in on the reality of it. Like I said with the train, if the Earth was moving, comparing it to the train, doesn't matter how you calibrate the instrument. As soon as it displaces, as soon as it accelerates or decelerates, it's going to detect that, and it didn't.
Brian, if you're on the train and you calibrate out the motions of the train, it's no longer going to measure those motions. You've zeroed them out. That's what they did, because they were looking for a distinct signal from the ether. They were not trying to measure the motions of the Earth. They wanted all of that to not be a factor. So they zeroed it out so that they could get one signal and make claims that it was from the ether, and that's what they were proving.
They assumed the ether was stationary. You are wrong. You obviously, I'm not even going to argue obviously haven't read it on
So
this.
now
They
you're telling
a
me that they
stationary
weren't
ether,
trying to
bro.
prove the
They
ether,
assumed
Brian?
a moving Earth. They assumed the Earth's movement, and they assumed a stationary ether. You are wrong, dude.
What are you talking about? So you
The
think they weren't
experiment.
trying to measure signals from the ether?
They
What do you mean
assumed
signals? Hold on. What do you mean signals from the ether? What do you mean it's signals from the ether? Can you define that, or can you give more like detail or specificity to that?
Yeah, they had multiple hypotheses because each one kept failing, so they kept trying to update it
No,
about
I'm not
how
asking what they did or did
there
not.
would be a.
Chase.
Okay,
I'm
just
not asking what
interrupting.
they did or did not do. I'm asking what you mean by signals from the ether. Just that term.
Yeah, so they had multiple hypotheses, beginning with ones that were like the ether was stationary and there would be this drift as you rotated the device and things like that, or that you could keep it stationary and there would be a drift from the ether when you were going one direction versus a different direction in the Earth's orbit. Did all sorts of different things. They did things at different times of the day. They did things at different times of the year in different locations. But they were all based on either there was an ether wind that would cause a signal, or there was an ether drift that would cause a signal.
Okay, so when something like the Michelson-Morley, when they detected a fringe pattern, but it wasn't the one that they expected, what caused the fringe shift?
They didn't detect
Whoop, there it is.
Well, they detected one within the just random fluctions of the instrument is what they reported.
No, this was outside fluctuations of the instrument. This was not within instrumental
do you have
error.
the paper where they report that?
Yeah. Michelson-Morley wrote up the paper. You obviously haven't read it.
No, I have read their original paper, and they certainly do not report.
And can you cite from their
outside.
original paper where the fringe shift that was detected was considered
I'll
instrumental
post
error?
the original for you.
No,
Yeah,
give me the specific part.
have the
That is
original
a citation.
paper.
Like you're writing a paper right now. Give me the citation for the specific verbiage that backs up your claim that the fringe shift detected was instrumental error.
You're the one making the claim that it was outside, even though
made no
even
claim.
your own people say that they claim that it was within instrument error, and now you're telling me that it wasn't, right? It's not on me, man. It's in the paper. I'll provide the paper for you, and you can read it and see what they say. I'm walking right now, so I don't have like a highlighter where I can go and I'm not at my computer where I can like highlight this thing for you. I'll tell you where it is in the paper. You can look at it.
We're walking here.
He's making shit up, dude. He's just on the spot. And because show me in the paper when you get a minute where it says anything about, bro, you're making shit up, dude. It's weird.
Brian, you before said that it was within instrument error. Now you're changing your stance on that?
I'm just claiming that's what they say. They say that it's minute.
They say it in the paper, Brian. That's where they say, where they reported their results.
You understand? I'm just trying to get you down to the common sense of it, of what was on the screen. And for some reason, you won't go there. I mean, it ain't surprising, but if you would just get your mind out of the Newtonian and all the calculations, just the screen itself, okay, should change. If the world works the way you say it does, the way they claim it does, okay, then we would get a change different times of year. We don't, according to them.
Do you know that you can come on an airplane with me, right? We could take a ring laser gyro and a fiber optic gyro, whichever kind you want, with the screen, right? And we can let it, pick up the motions of the airplane, right? And then we can calibrate it to that motion and see that it'll then disappear. It won't be picking up a signal anymore.
Really?
Because we've set the 0 point of the graph at that acceleration velocity, or the acceleration that's causing that peak, right? We've set the 0 point there. So it'll no longer pick up the signal.
So then you're saying that it just zeroes out everything from there? So no matter what I do to change the speed.
You'd have
I've
to have
changed
a
the slow
larger.
the speed up. You're saying that it just stays at that zero. So you got to show me this magic dynamic calibration. You're making
You'd
shit
have
up,
to
bro.
have a larger acceleration, a larger force than it would measure, right? Because you set the 0 point at that original.
That's what you're saying. You're saying.
Yes, this is how instruments work. It's like instrument
now we need a
101.
big acceleration. That's not a calibration. That's called screwing up the device. If all you did is now you just expanded the parameters.
You're breaking up. It's more correctly just called zeroing. You set the 0 point of your measurement to a specific value, right? And so we can do that. We can get on an airplane. We could tell the pilot, take a consistent turn at a specific acceleration, a specific force, and we could set the 0 point at that. And the graph will no longer read a signal until the pilot causes a larger acceleration. It has to be above that 0 point that we've set. This is just how instruments work.
So they dulled the sensitivity of the instrument. Let's say I take a radar gun and I calibrate it, and I know this one thing is going a certain speed. I know this pitch is going 100 miles per hour from the middle 10 meters of the pitch. Okay. Now here's the thing. No matter how I calibrate it, and yeah, unless I just dull it out, like you're saying, maybe I think that might be what you're saying. But if I calibrate it to where now showing 95. I took away some of the sensitivity. It's not really, but as soon as the speed of that ball changes, it doesn't matter how you calibrated it. It's still going to show change in the speed. If the speed changes, then it doesn't matter how you calibrate it. You're going to get change unless you just totally.
Not if it's slower than the calibration point you set. If the graph can't go into the negative values, if the speed then becomes slower than what, and it's only positive values that the graph can measure, it's not going to show you anything.
So it was calibrated right, and it was showing 100 miles per hour. I've dulled the sensitivity down where now it's showing 95 miles per hour. What if I then throw a ball 10 miles per hour? Is it going to still say 95, Jay? I changed the speed.
No, it would just say 0. That signal for the 10 mile per hour would be lost in the noise at the baseline because you set the 0 to 95 miles per hour.
No, I've set. Okay, let me rephrase that then. Dude, you're just looking for ways out, bro. Like Dig Dug or something.
It's not a way out, Brian. This is how instruments work,
I've got the scale calibrated at 0. Okay, Jay? I got it calibrated at 0. I throw a ball 10 times. It shows 100 miles per hour in the middle 10 meters, okay? Then I change the calibration to +5. Now, when I throw the ball, okay, I keep getting a 95 mile an hour reading, okay? Now, as soon as I slow the pitch down, I've changed it, I've recalibrated it. Now I changed the pitch to 20 miles per hour. Okay, now it's just going to show 15. It's not going to still show 95. If it changes, once it's calibrated, dog. It's made to detect change. It's what it's made to detect. The interferometer is displacement. Yeah. Any change in direction, any change in speed is ridiculous that you're arguing that, saying that they're just calibrating it
I'm not arguing that. I agree with what you just said, but they're in their paper, they provide the equation for how the calibration, the 0 point that they set for where 0 fringe shift is on their detector. And it's set to the predicted velocity of the Earth orbiting the sun that Newtonian mechanics gives you, which is a very large velocity, right? Because they didn't want to measure those kind of signals because they were hypothesizing about the ether. So they wanted to only measure signals that were above that coming from the ether. So they could point to those signals and say, look, this is definitive proof of the ether.
No, the only reason they use the ether is to have something to compare it to. It's like saying I'm going to measure the speed of this swimmer in the water, okay? And I don't get the right accelerate. I don't get, and come to find out the swimmer is barely moving, okay? So what I do, abolish the water, basically, is what they're saying. That's what Mickelson Morley did, is they just abolished the fucking water, or the ether. Instead of dealing with the fact that the swimmer was barely moving, they just kept the assumption, instead of even maybe moving the water, maybe it's current moving the swimmer. They could even went there. That would, or they could say that the swimmer's not moving, right? They just abolished the water.
Yeah, that's a good analogy. It's like it's like they have a fish in the water, right? And they're trying to determine, is the fish moving because of the current or because of the fish is actually moving through the water, right? Is the water moving the fish, or is the fish moving in the water? And then they just decide, well, there's actually no water to begin with because we didn't detect this one motion, so therefore there is no water.
No, you would have to zero out the signals from the boat that you're on.
You don't even,
because you want to measure the signals from the water or from the fish, because you want to point distinctly to those signals being what you're hypothesizing about. So you don't want signals from other things being present. I don't know why this is such a hard concept for you guys to grasp. I don't get it.
Bro, you're not.
So how did they eliminate the ether if they were zeroing out for the ether? So they just zeroed the equipment out.
They didn't zero out for the ether. They were trying to measure signals from the ether. So they zeroed out for the predicted value that Newtonian mechanics gives for the acceleration of the Earth around the sun.
This is why I was trying to get you to properly define the signals from the ether, because the experiment was set up based on the assumption that light propagates through the ether, meaning light is a wave within the ether. The ether is what substantiates the light to begin with. That's why they used interferometry, right? Because what is used in interferometry? What is the mechanism that you're using to measure?
Yeah, I totally agree with you. But they wanted to show distinctly that changes in the fringe shift, or the path of the light, was because of the ether and not because of any other motions. So they zeroed the graph out for those other motions so that they could point to any signal as being distinctly due to an ether effect.
So in the Mickelson-Morley, where they're trying to detect the Earth's movement around the sun based on a stationary ether, so they were just trying to detect the ether in general?
Yes, they had multiple different
You're so fucking wrong. Why does everybody get this wrong?
How they were trying to detect. They had multiple different hypotheses. They were trying to measure it in multiple different ways, including doing it at different times of the day, different times of the year, putting it on a device that could float on water, keeping that device still, rotating it, because they had all
floated
these
on Mercury
ways that
floated on
Mercury.
You don't even understand what you're talking about.
They did it on water too, genius. But nonetheless, they had all these different hypotheses for the ether that they kept not getting results for, so they kept altering it and doing it in different ways. But nonetheless, I got to go. Now you're just using a tactic. Nobody's making anything up, Brian. It's right in their own paper, man.
Yeah, it's in the title where it's trying to detect the Earth's motion around the sun through a stationary ether. That's literally in the title. So for you to say they weren't trying to detect the Earth's motions around the sun is just disingenuous. I don't know if you guys actively, intentionally try to misunderstand this experiment so that you can claim that there is no ether, or that it's been taught that way so much in academia that it's taught so incorrectly that it's just been brainwashed into you people, and you lack the critical thinking skills to be able to actually critically analyze what actually took place because you just heard somebody in school.
How do you detect
Enough with the gaslighting. You're not smarter than all of academia. I'm sorry, man. That's just not the case. I didn't
say I was smarter than all of academia.
You don't know better.
No, that is the gaslight. Saying something like that is the gaslight. Pause a second, Jay.
All the
He didn't say anything about being smarter than all of academia.
And how the experiment works.
Hey guys, can I play the role of breaking up the fight so we can get back to the convo? Because it was good there. There's some good content. Can we get back to that?
Can I ask you a question?
I've got to take off anyways. So I'll post the paper for you. You can start there.
Jace, can I ask a question? Jace, can I ask you a question?
Just post the title.
Make it quick.
Just post the title.
How do you detect the ether?
Yeah, they had multiple hypotheses for that because they kept getting no result, right? They had that you would get a drift, right? If you just kept it stationary, that when the light was going in one direction, the ether would affect its path so that there would be a change in the fringe shift and a distinct measurement that they could point to at a distinct value to say that they've measured an effect due to the ether. And they had multiple formulations
but the ether itself. But the ether itself. I mean, at best, you're just realizing direction of light. But how's that detecting the ether?
Because that's what they wanted to do. They wanted to get a signal. They wanted to have the path of the light affected to give a signal that they could point to and say, it can't be anything else. We've calibrated and we've considered all these other things that this signal can potentially be from. So it can only be this predicted value from the ether causing this signal.
The idea, the reason for the ether is the reason why they thought there had to be an ether, and they were trying to figure out how the ether worked, or if there was an ether drift, had to do because information, matter, like if it was going to be particular in matter, like it needs to be through a medium. It cannot be in a vacuum. Okay, so
waves have to be right. But here's the thing:
they were measuring light, not matter.
Look, and here's
light needs a medium. Light needs a medium. If it's going to be a particle, it needs a medium.
No, it doesn't.
What?
They had not.
A medium?
They had not come up with
medium. A wave needs a medium, but this is the point. Napalm was right, dude. The name of the experiment, Jay, is measuring the motion of the Earth through a stationary ether. They're not if they were measuring for ether, like just take something where they know the speed and just put an interferometer on that and measure the fringe. So everybody forgets what the actual experiment is.
Okay, what is the fringe?
It's manipulating the light and the fringe, you know?
Yeah, the fringe. What is the fringe? That's the whole point. You're getting to it. So what is the fringe?
About this, I have a steady line of water, okay? And I'm spraying a perpendicular to my movement, okay? Then on that screen, okay, then I will be able to look at the water and see that it trips out because it's basically conserving momentum, whatever. Okay, light doesn't conserve momentum. Okay, so they use light to do this. So now, in other words, if you travel forward and the light you shine the light perpendicular, then it shouldn't. Man, I'm brain farting, man. But you see what I'm saying?
No, but okay, quick question.
Can I explain why I said? Can I explain why?
By the way, the name of the paper is not what you guys have been saying. The name of the paper is on the relative motion of the Earth in the luminiferous ether, right?
Correct.
So if you're trying to measure the value of the motion of the ether or the drift of the ether, how can you measure that if you're not calibrating the predicted value for the motion of the Earth? You would just have a bunch of signals jumbled together from that motion. You have to calibrate that out to measure or zero it out to measure a distinct signal that you could point to say that this is due only to the ether.
So who's to say when you're calibrating, right? Canceling out. Who's to say like you're calibrating against the movement of the Earth, but the Earth is actually moving.
That's what Aries failure was doing. Aries failure was doing exactly that. Like it would either be like a resistance and a delay in the speed of light, or there would not be. And it had an expected result if it was going to happen, according to what was the modern physics, the idea of it. And that's why, again, why it was a failure is because he didn't get the expected result. So
no, the Aries failure. Let's start with the calibration thing first, right? The calibration or the zeroing out. All that means is, right, you have your device, you have your interferometer, and it has a detector that's linked to a computer, or back then they may have had something else that would have a graph printout. Calibrating it or zeroing it just means you're just shifting where the beginning of the graph starts, where the zero point actually is.
Yeah, that's an assumption.
It's not an assumption. It's just moving where the zero of the graph is. There's no assumptions. What are you talking about?
Why are you moving?
So they were just zeroing.
Why are you moving the zero?
They were assuming, right, because they wanted to be able to point. Their objective was to be able to point to any signal they measured and said this is a distinct predicted signal of the ether. So they had to zero
their method could have been
any
erroneous.
other
potential. That's through what? What Aries failure?
No, this is
what
Michelson Morley. Aries. George Airy, if you read George Airy's paper, he was testing the undulation. He names Professor, it starts with a K. I forget the actual guy's name. It's like Klinkenford or some weird name. But he had he had an undulation ether theory hypothesis. And that's what Airy was testing. Airy was testing this undulation ether hypothesis. And he found that it wasn't matching with the predictions that the professor was giving for his undulation ether being present. He wasn't getting the results that he should get if that was true.
Every experiment that they do, and it shows that the stars moving. They just bring up the ether to abolish it. That's what they did. They just rewrite the paper. There's a straw man in the paper itself, and Michelson Morley straw man the whole experiment. But here's the problem: the results are still there. We can look at what they did, and we can determine the results for ourselves. Okay, we don't need their straw man names and just come up with the ether and tell me what it's doing. Just assume the ether stationary, just to abolish it. It's ridiculous.
There was a million different hypotheses of the ether because every single time they kept assuming that there was this ether, and all the predictions that they were making from the presence of this ether kept not panning out. So they had to keep changing.
They made a ton of predictions based off of the ether ideas. They were successful many times with using this ether hypothesis.
Sorry.
Why did they keep having to alter it and keep doing different experiments to try to find the ether then if they were so successful?
If we set up the experiment, the logical conclusion is that there's no motion. The logical conclusion.
No.
The motion we assumed is not there. You don't think that's the logical conclusion from the experiment setup?
No, that's not the logical conclusion, Raj.
Well, the thing is like even with the modern idea of things, like you guys are wrong more often than you're right, but you only focus on and talk about the things that you're right about. Well, the same shit happened when they were talking about ether. Okay, they were wrong probably more often than they were right, but they still got a whole bunch of shit right. It doesn't mean that your modern interpretation of how things work is more correct or more relevant than the things that they were fucking doing. It's just that you had to try to come up with a new idea to fit something you were working on at the time, but it's still full of holes. just as many holes as what the ether hypothesis had to do with. Like, in fact, maybe more. Both are freaking, in my opinion, ridiculous. Like, I don't think either one has it figured out.
Can I ask a question to like both sides? Like for ether, against ether? What is ether? Can anybody, like in this conversation, you've all brought it up. What does it mean? What's the ether?
That's something that nobody can fully describe. People will be they won't agree necessarily, but it's a background medium in which all of physical reality basically like is within. Think of it like a current in an ocean, and like everything within the ocean has to move with it. Like the ocean is moving, and so everything in the ocean moves with it. Like
if light is a wave, a wave ain't what. So there's got to be a medium for
light isn't a wave though.
Yeah, that's the funny thing. Like
you don't know that. In fact, you guys say that light is both a wave and a particle, which is totally in contradiction.
Quantum physics says light is a wave right now.
Hang on, guys.
Light is certainly a wave.
Guys, these experiments you're pointing to, even if they did pan out the way the experimenters wanted them to pan out and they proved the ether that they were proposing, it's not the ether that you guys are proposing. So like you're pointing to these experiments as proof of something that you don't even support. Like your idea of the ether is not what they were doing these experiments for.
The whole debate that's been going on is, are we moving or not? That's what the debate has been. Say, well, we already know
they had a very
distinct. Never been moving. So Michelson says, quote, he built the device, he invented the device to detect the Earth's absolute motion. That's what he's going for. If they want to try and change all his shit, bro, the argument has been is whether we are moving or the stars are moving, bro. And there's no experiments that claim that. They all change it because they never got the result. So they change the names of the papers and do all this freaking mental gymnastics to keep the Earth in motion.
This is just conspiracy that people are changing names of papers. Brian.
No, Jay, what you're trying to say is because the people who are talking about ether also believed in a globe Earth, but they were more arguing whether or not it was geocentric or heliocentric, and whether or not there was an ether.
They had a very distinct and definitive definition of what the ether was, and it's way off from what you guys are
and
proposing.
It's not really a definition. I mean, to
so
claim
even
that
if their
ether is a medium
panned out, it doesn't prove what your version of the ether is, because that's a totally different thing.
I would agree. Yeah, I would agree with that statement right there. I mean, just
so pointing
the
to
ether
these experiments as there's some kind of proof for you guys is silly.
That's not contradictory to what I had just said. Is that people's ideas of what the ether is are not like necessarily in alignment. Like everybody's, if you're going to ponder an ether, like it's hard to find two people who have the same idea. Like that's absolutely true.
So it's not a medium then.
A brain fart.
No, it's an idea. It's an idea like dark matter or fucking matter, like mass attracting mass, space time.
Yeah, so it's not physical. It's just.
Hey, see if Lou's got me turned down, y'all, real quick. I don't know. I don't think you get.
No, you're good.
No, I was in. No. You started talking while I was talking, so I continued. But go ahead now. Now that I'm done.
Okay. Now, when I was talking about light not conserving momentum earlier, okay, we can't use. It's going to move along with the motion, okay? But light doesn't conserve momentum, okay? So they use light. So what they were trying to detect is the motion of the fucking Earth. I don't care what they say it was through. They were trying to detect the same thing with Aries. They were trying to see if the stars were moving or the Earth was moving. That's always been the debate. It's never been settled. It really has been settled. They've got us in the weeds arguing about fucking ether when what the light shows is we're not moving around no sun. There's no orbit. They come up with all these fucking bullshit excuses and got us arguing about
The
ether.
reality is
I would
totally
say
opposite
bullshit
of
experiments that
that.
don't prove for or against anything. It's just bullshit experiments.
Because
that's
oh my God, Brian, you do know there are VLBI and Doppler experiments that do show the motion of the Earth around the sun, right? When you have these single reference frame interferometer experiments in a lab on the Earth, yes, it's on a geodesic, so you're not going to pick up motion there. You have to do a different kind of experiment. 2 examples are using the Doppler effect to pick up the measurement and using VLBI, which is very long baseline interferometry.
Exactly.
Which
that's
creates
not an experiment.
a reference.
That's a mathematical equation.
No, VLBI
yes,
is not a mathematical equation. It's an interferometry technique that can create a reference that is not just a single point in a lab. It can create
I agree. It's technique, but the technique is a calculation. That's all it is.
No, it's a measurement. You use telescopes and interferometers to make a measurement.
What's the measurement? What are you measuring? Is it
They're measuring
meters per second? What's the unit?
No, it's the fringe shift, the frequency, the fringe shift, right? And then that
you said it's a measurement, so measurement has a unit. What's the unit?
Yeah, frequency, hertz.
Hertz. Okay, so you're measuring hertz, right?
Yes, and then that can be converted based off of the hertz measurement of the frequency. That can be converted to a meters. Bro. No, hertz is a unit. It's an SI unit of frequency.
Yeah, hertz is a unit, but
I agree to that.
What are you actually measuring?
Yeah, so you can calculate the hertz of an airplane taking a turn, right? And you can convert that into a velocity or an acceleration, which are meters per second or meters per second squared. So they do the same thing with these VLBI, which can use either just interferometers or they could use radio telescopes, and they measure the motion of the Earth based off of either a fixed reference on the sun or a fixed reference on the star.
Right?
No, it's a measurement. You just keep repeating that it's a calculation, but that doesn't change that it's a method of measurement.
If you're converting from hertz to meters per second squared, is that a calculation or a measurement? I mean, you voiced it yourself.
It's a conversion.
Exactly, which is a calculation.
No,
not a measurement.
It's not.
No.
So you're saying an airplane taking a turn that's not a measurement? The device isn't measuring the airplane turning? Like, what are you talking about, dude?
How would you measure an airplane turning in hertz? How do you do that?
Because the device measures a fringe shift of the light. It measures the hertz of the light wave. Yeah, that's an equivalent to a meter per second value. It's not a calculation.
Yeah. When you say equivalent, you put an equals sign between 2 results.
Yes, that
2 sides of an equation. It's an equation.
Yes. That means 10 hertz is the same thing as 20 meters per second. That's what it means.
Within a certain mathematical equation. A model.
That's just silly. You're silly. It's not a mathematical equation. It's 10 hertz is the same thing as 20 meters per second. It's not taking, I have an unknown value. I have some values for some variables, and I'm going to solve for the unknown variable. That's not what you're doing. You're just doing a conversion. So it's not just a mathematical equation.
It's a conversion built upon the model you built around this interferometer. Because you're claiming it's measuring.
Sorry.
Okay.
It's not a model. I can demonstrate that when I move the device a specific way, that corresponds or is the same thing as 10 hertz in the instrument. There's no model. I can demonstrate that to you.
Okay, so when it's sitting on a stationary object and it measures your alleged rotation of the Earth, how can you demonstrate that?
Exactly.
How can you demonstrate it?
Well, that would be one data point, right? We wouldn't take it
that
in
you
a
can't
vacuum.
demonstrate.
But your arguments are just special pleading, right? Because any other demonstration that I do for getting a measured value on the device, I have to put the device physically on the thing that's moving. Like an airplane, I have to put the interferometer on the airplane, or I have to put it on the ship, and the ship actually has to move for the device to register something. So if you're going to say, when it's just sitting on my lab bench and it's picking up a measurement, that isn't because the Earth is moving, as in all other cases how the device picks up a measurement is because the thing it's on is moving. If you're going to say it's something different in this case, then that is special pleading, and it's logically fallacious.
That's not what I said. But and again,
so the only logical
I'm no expert.
conclusion is the Earth is moving.
No.
Lou, would you agree that if a photon doesn't conserve momentum and it leaves a star, if we're trying to figure out if it's the stars moving or the Earth, would you agree that if a photon doesn't conserve momentum and the photon leaves a star, it's on a path straight for stationary Earth or moving Earth? Okay. So would you agree that? Hey, do you argue that photons conserve momentum? Are you trying to claim that they do, or anything like that? Anything crazy before we move on? Because here's the point. Easy to figure out whether it's the Earth or the stars moving, because the way the photons define, whether it's a wave or a particle, it doesn't conserve momentum. Okay, it starts in a linear path, barring no diffraction or refraction. It's on the way to the viewer. So what they do, all you got to do is slow down the light. And if it's already on a straight path to the telescope, then you won't have to change. You won't have to change the angle of the telescope. If no matter how much you slow the light down, it's already on the path. The Earth is stationary, so you could slow the light down to a creeping halt almost. It's just going to trickle its way right to your eye. But if it's the Earth moving. No, I'm almost done. If it's the Earth moving, you slow that light down, and if it's us moving, it's not going to make it all the way down to the bottom of the telescope. When we put water in the telescope to slow the light down, we'd have to change the angle. That's just obvious common sense. And the fact of the matter is, they did not angle because the Earth is not moving. It's got to be the star.
No,
that's Aries. You're talking about Aries failure.
But you did.
Yeah, that was genius. Simply brilliant. 100%. It's demonstrable, repeatable.
It's like, just read. Like, why don't you guys just read the papers from these people? Report what they were doing and the results that they got.
The minutiae
I don't understand these making up things about what they were doing.
Did
George
Aries
Airy
put
very
water
clear.
in the telescope, or did he not? Did he put water in the telescope?
His paper from the Royal Society in Brandon Toy's server a few times.
Write it up,
and
Jay.
I highlighted what George Airy said he was doing, what he was testing, why he was testing it, and his conclusions from the results he got.
Jay, we can repeat this. It's been repeated. We don't got to listen to the bullshit they put on paper. It's repeatable. Would you disagree with the light?
Scientists report their findings in paper. That's what we do.
It's repeatable, bro. We keep thinking about the papers. Think about the experiment itself. Would you agree that if the Earth is stationary and the star is moving, once the photon has left the star, it's on a path to the telescope, and no matter how much you slow light down, it won't change angle. It'll still make it down to the eye. If the Earth is not going anywhere, remains on that path.
You'd have to show.
Do you agree with that?
You'd have to show the actual predictions, aka the math. And the correct math too would have to be math that's actually correct for what the globe says, the velocities that the globe is moving. You'd have to show that it actually does predict that the light should not make it to your eye or whatever you're trying to claim. Right. I would have to see that first to agree with you, Brian.
So I started with the stationary Earth, and don't think about math or any of this. Just think about the common sense of it. If a photon is on its way to this is the question. Don't veer off from the actual question I'm asking. I'm not trying to trap you here. I'm just trying to see if you agree with the common sense of it. If the photon's on a straight path to the observer, and if the observer is not moving, then it's going to just go straight down, even if we add water or don't, straight down to the and hit the eyeball basically, or the eyepiece. And then if we slow it down, it's going to do the same thing if it's the Earth stationary. So we can repeat this, which they did, and you could write it up. Here's where you need to write up a bunch of bullshit. If you didn't get the results you expected, and you want to keep the Earth moving, and you got exact opposite results, then you have to write up a bunch of shit and throw in a bunch of news. That's my point. We can repeat these experiments. It's the results of the way you described are in the paper, not all the bullshit.
Yeah, exactly. And he went more than just surface level deep than you have here, right? Like what you're saying is true. Sure, that's one possibility, but you can't then like make these massive leaps in logic that because you got those results, you haven't ruled out any of the other possibilities, which is what you would have to do before you could conclude, okay, we've ruled everything else out that I can think of. So now I can actually have a leg to stand on to conclude that, yes, it must be that the Earth is stationary. Right? You have to actually do the work first.
Once again, is that the Earth is stationary. That's the logical conclusion from the actual experiment. Before we dive into
not the only conclusion, though. That's the problem.
Logical conclusion from our prediction.
It's one of them, Brian. It's one of the logical conclusions from the experiment you described, which isn't even really what he was doing.
What's another logical conclusion? Can you enlighten us? Like,
yeah, the other one is that the relative motion between the Earth and the star is nowhere near fast enough that the photon would be blocked by the side of the telescope or whatever other kind of blocking you would try to claim, and thus it still makes it to the eyepiece.
But when we look at other things,
Brian, real quick, J.A., we've got somebody here that's done a lot of work on this right now. I'd love to hear you and Alan go back and forth one-on-one for just a second on this matter, if you don't mind.
Well, I do have to take off, but
yeah, I'm sure you.
What does he want to say?
Yeah. Okay.
Well, I've been here for hours, just kind of repeating
well, now
myself.
It's going to get really bad.
We'll sit back. We'll sit back in minutes, Jay, and we'll let you go.
It won't take long. Don't worry. Alan, are you there?
Yeah. So can you kind of summarize what you were saying? I just kind of got here. New perspective was wanting me. Let me introduce myself first of all. It's nice to meet you. My name is Alan. Dave was telling me that you were talking about interferometry, and and he knows that I'm also researching the subject, and he wanted me to to talk with you, kind of have a back and forth. But if you're about to go or whatever, like we can postpone or do it later. But if you wanted to like quickly summarize, like what you were talking about the last 5 hours or whatever, I'd be happy to have a conversation with you about it if you're interested.
Yeah, I mean, I don't know, can't really do it quickly. And like I said, I've been here for hours now. I do have to, I have other stuff I have to do.
No, absolutely.
A quick summary, you ponder it, and we could talk another time, I guess. It was just the George Aries failure thing. For some reason, this is being represented as some kind of Earth motion test, when you can just read George Aries' paper. I've posted it from the Royal Society paper that he published. I put it in Brandon Toy's server back in the day. He doesn't say like anything about that. What he does talk about, though, is this undulation ether theory that Professor Clankenford, it starts with a K, Clankenstein.
Yeah, Clankenstein or something.
Yeah, he talks about how he disproved that hypothesis of the ether with his test, but for some reason it gets represented as some grand Earth motion test here that Airy was disproving. And then we were just talking about some of the Michelson-Morley stuff earlier, but like I said,
yeah, you were saying Michelson-Morley was all about the light. Were you saying it was all about the light, testing the light? Was that what you were saying, Jace?
No, it was about the ether again. They had multiple. Right, there wasn't just the Michelson Morley.
The ether with respect to what, though, right? You know.
Yeah, there was the relative motion of the Earth in the ether. So they had like hypotheses of the ether wind, the ether drift, a stationary ether. They modified the hypothesis a few times, and different people got in on it. Like there was the Gale experiment as well, the Michelson-Morley experiment. There was another German guy in 1921. He did the relativistic legwork on the Sagnac effect. His name starts with a L. Yeah.
Paul Leveau.
Yeah, exactly. So ponder that stuff because I do have to go. So we could get into the details another.
Yeah, but you have to give Alan a little bit of a response there before you go.
Dude, come on. It's such a long like it's not just like a quick, like it would be you know, lengthy because it's like he's right. It is a
Well, he thinks
that's all.
Wait, real quick. Alan, did the Michelson-Morley experiment disprove the ether as J.A.C. is trying to explain to us here?
No, so the interpretation, so measurably, right? So the effect of the ether, right? Conceptually, like what its purpose is when they say all motions relative to the ether and what that means in terms of electromagnetic propagation. So an observer's motion would show a variance in the speed in which they receive light relative to the ether. So like there would be a proportional relationship. So for example, with Sagnac with their rotating device, you can find a directly proportional relationship to the angular rotation with the fringe displacement, right? So what that means is that for a rotating effect, they say that that works, but it doesn't work linearly, right? But that it was shown in 2004 that it does work, and also expanded upon from the Sagnac effect was Dufour and Pruner, who in 1942 reproduced the Sagnac effect in its traditional setup, and then they did modifications to it as well, where the photographic recorder and the source of a light emitting were fixed to the lab, and then it was just hitting an empty rotating device with just the mirror configuration, and then they would take the readings, and they still found that the angular rotation was translating its motion to a stationary receiver, which is not good for special relativity, but also in regards to multiple. Sorry, I'm kind of all over the place. I'm just trying to like broad stroke your all the points you were talking. In regards to multiple ether theories, there was tons and tons of ether theories, especially by the grandfathers of electrical engineering, and they were all trying to explain various phenomena. And a lot of the reasons that these theories would fail is because the relative motion of Earth's velocity has never been measured. So if Earth was truly going at 30 kilometers a second, that would have been reflected in the Michelson-Morley experiment, because linear motion, like I said in 2004, was proven to be measurable by fiber optic gyro. Like it's not I'll tell you what the guy did. He took a fiber optic cable. He turned it into a conveyor belt configuration, and he found that the linear segments contribute to, produce the fringe pattern, like the full amount. And also he had another thing tethered to it, another fiber optic gyro tethered to that, and that was moving in a linear motion, and that also registered it. So he proved conclusively that linear motion would have been measured. So.
Hi, Alan.
What up?
Quick question. You said there are many theories about the ether. Do you subscribe to any one of those specifically, or?
Yeah, I think the Earth is stationary, and there's a uniform translation of motion matching the sidereal rotation of the sky, and that's what like Michelson-Gale, for example, measured. Because there does seem to be a variance in the speed of electromagnetic propagation relative to the latitude, but the way that they explain it to us on the globe is they say that it's like a symmetrical thing, where when you get to the equator, you don't get a reading because technically you're not moving and whatnot. But then as you get further away in the southern latitudes, that the readings would again start matching the northern. But we don't actually have any single axis gyroscope readings in the southern latitudes. We only have northern gyroscope, or let me rephrase, the only evidence that I've been able to produce of such readings of a single axis gyro are in the northern hemisphere, and they're all right around the 45th latitude. So they're basically making correction angles to Polaris. So they're essentially aligning their device with the rotation of the sky to get the best reading. Now on the globe, they say that they're aligning it with the axis of rotation of the globe. But either way, from the only thing I've seen is northern hemisphere correction angles that would match a plane as well as a globe. So
Okay, can you real quick just tell me what is ether? Like, what is it? Can you define it?
Yeah, it's the background medium which all motion is relative to. That interconnects everything in the universe. Like, so when they say like light is propagating through empty space in a vacuum, they have to come up with a lot of mathematical reification fallacies to even begin the justification for that. But the old, much simpler understanding of it is that there's a wave needs something to propagate through, right? As Austin says, I can hand you my wave, but I can't wave you a hand or whatever, right?
Well, I mean, if it's a medium, I'm guessing is that a physical medium? Like, is it made of something? Or?
So there was an experiment done by what's this guy's name? Oh yeah, Yuri Galev in 2004. We're using optical wave bands. He measured the viscosity of the ether. So he measured the quote unquote physicality of it. But I have not delved into that experiment enough to speak on exactly the physics of that. But yeah, that guy apparently did measure that.
Yeah. So you don't know what the ether is made of.
No.
Right? Yeah. But
Correct.
you're sure it's there.
Yeah, we could see we can see the effects of it easily, demonstrated in electromagnetic propagation to a high degree of specificity. Like when you say like, is it a material substance? Can I touch it? It's like, well, I don't know about all that, but the descriptive motion of what's going on with it and how it interacts with electromagnetic propagation relative to the observer seems to fit the an etheric framework by which there's an absolute reference frame to which all motion is relative to.
Yeah, I agree with that. No, well, by saying it's physical, I'm not saying you can touch it. I mean, light is physical. You can't touch light, but I would say no. Let's move on from that. You said light is a wave, right? You were talking about how light is a wave, right?
Electromagnetic propagation, yeah.
So you're going against basically modern science, because modern science defines light as a particle.
Look
right?
it up. No,
as a particle. There's multiple interpretations for the double slit experiment, and I can actually link you a video to achieve. Like, this is just anecdotal, obviously, but this woman is I think she got her master's or PhD in physics and whatnot, and she during COVID lockdowns, she got bored and reproduced the double slit experiment for herself, and from her understandings and teaching is that it's a wave particle duality relationship. And when she did the experiment herself and did the readings, and she concluded that it's not a particle. Like, she completely changed her whole worldview. It's a really interesting video. If you're interested in that,
no, I am. I'm aware of the double slit experiment, and the wave aspect in the experiment is just a mathematical construct. It's a probability distribution. That's what the wave is in the experiment.
No. You're confused. Hold on one second. Let me show you the breakdown of the photon. It's the momentum that they say that allows the vacuum propagation. That's the mathematical reification fallacy. Like, the other part's just a description of a wave frequency. Like, it's nothing like dubious or whatever. Let me show you the exact equations.
Yeah, I'm saying that the wave aspect is just a mathematical function of the probability distribution of the light particle on the
negative. I think you're describing something else. Give me 1 second. I'll show you what I'm referencing.
The double slit experiment. You have two slits, right? And you're shooting discrete particles of light, chunks, whatever you want to call them. They're distinct. You're shooting. Well, let me just explain it how.
Yeah, go ahead. You're good. Go ahead.
Yeah, my understanding. So you're shooting chunks of light, like on that the plate, right? That's where you're measuring the light. If I shoot one particle, like one discrete chunk of light where you get one reading on that plate in one place, right? How is that a wave? How do you like then translate one reading on the plate into a wave? Can you explain that? Because my understanding is it's the multiple readings that
like
allow
a
for.
bucket of water.
Yeah, let me just finish.
And then just take a little drip water and fire it. So are you saying that the water doesn't make waves just because you fired a tiny bit of it? That's ridiculous.
Well, in the context of firing droplets of water, you're not creating waves.
Right, but that doesn't.
If you're
make
trying
it,
to give an analogy,
make waves just because you just shrunk it. You look small enough, you're going to see the wave.
Yeah, see what I asked for. I mean, I just explained how you get. I was in the middle of. Let me just finish. So when you get multiple readings on the plate of these discrete chunks or particles, right? You can create what's called a probability distribution function, right? It's a mathematical function, right? It's how you predict where the next chunk is going to be, and it's a wave function. It's a mathematical equation. But what I'm trying to understand, when you say it's a wave, like I just explained how I think it's a wave or understood to be a wave, how do you understand it to be a wave?
Check this out. If I fire a drip of water and I don't have a detector there, I have a detector there, and I know for sure it went through this slit, then it didn't diffract with anything. So it left just two straight lines. It just basically formed a bigger version of the two slits in the background. If I don't have a detector and I'm firing these things and they're diffracting, they're touching the slits. In other words, the only ones I can say for sure are the ones I detect that are going through, making just the two line pattern. But every other one that I can't zero down is they're not going clean through. They're diffracting. We know what causes diffraction, called interference. So once it's inside of a slit, then we don't know which one it went through or if it interfered. So that one doesn't count as going straight through. It's hard to explain, but basically, if it touches the edge of the slit, it's going to interfere no matter how big it is. Yeah.
Hey, Brian, real quick, will you let Alan respond? I think he was trying to ask Alan why he thinks it's a wave.
Yeah. Hello? Okay. Here we go. Okay. So there was the first thing I posted was the equation to describe what they say is a photon, right? So they have just the regular wave mechanics stuff there, nothing fancy in the way that you were talking about wave probability and whatnot. I think you're referring to what was that, like Schrodinger's equation or whatever kind of thing. Like we're not talking about the same thing in this respect right now. So just bear with me and why I think it's a wave, right? So the normal equations that describe a wave function, the frequency and the what's it called? Like the amplitude of the wave, right? So the physicality that they had to come up with to describe vacuum propagation is the mathematical reification, where they have Planck's constant divided by pi, so that it always scales proportionally to zero, the energy of it, right? Because the physicality the energy would have to scale proportionally, at the speed of light. So if it were physical, it would have infinite mass and all that, but they can't have that because that's retarded. So they just mathematically reify scaling it down, but they say that it exists. But it's just like a fancy that's a trick, right? Like that's the kind of trick that you're kind of describing, right? So like there's a deception in that where they hide it in way, because these are all wave equations to describe a photon, right? And then obviously the classical way to describe momentum would be mass times velocity, right? So, but the photon has no mass, but it needs momentum to propagate through a vacuum, right? So that's step one, right? Now, step two, the other things that I linked are the electromagnetic wave model, right? So you have your oscillating electric wave and your oscillating magnetic field going perpendicular to that, to the direction of that direction of propagation. And as you'll see in there, I highlighted three of the intersection points of that wave, right? And then if you click on the next image there, you'll see Maxwell's equations, and you'll see Ampere's law with Maxwell's corrections to it. So what Maxwell did here with the Maxwell's displacement current is he said that intersection point, that charge potential that's required for electromagnetic for an electromagnetic wave to exist, like it has to be accelerated. Otherwise, the electric current can't induce anything. It can't self-induce the magnetic field without a charge potential in between it. And that charge potential is the ether. That's that charged accelerated form of the ether. So when that hits the photographic plate and whatnot, like, yeah, like you could register that event as like a particle for like the double slit, right? But the interpretation of that varies wildly from the wave function of it doesn't exist at all, and it was a particle the whole time, right up until it decided arbitrarily based on the observer looking at it, right? Like completely different situations in that regard.
So you think, like, you agree with the idea of particle wave duality? Like, you think
no
light? Okay, so you think light just behaves as a wave. So how do you interpret the experiment, the quantum eraser?
In order for a photon to even exist, to propagate, there has to be an accelerating charge potential. That's the ether inherently in the mathematics. That's what they've obfuscated with that reification fallacy. And the way they teach electrical engineering, and all that in physics, the way that it's taught is that doesn't have to exist. So their natural interpretation is when that registers the whole time, when that charge potential registers the whole time that it's existed and never not existed. They're like, oh my god, it's a particle of some kind. It's right. It's it's not what you. I don't know. The whole
bro, it's math. They reified the mathematics and call it a particle.
Yeah. Like this is how they've obfuscated it.
Around. I think calling it a wave is a reification of the mathematics, because what it actually is, in the experiment, you can shoot one chunk that just makes the reading on the plate as one dot. It's one dot, right? So how do you go from dot to wave? I can explain a dot by being a particle, but how do you explain it as a wave from just getting a reading on that plate?
So when that accelerating charge potential hits the wave, what do you think happens to the accelerating charge potential?
I don't know. I wouldn't know.
I mean, there's your dot.
Well, if you can explain that a little more than just charge
yes.
potential, like what's going on?
Yeah, so in that regard, I don't actually know. The only thing that I know about the charge potential in electromagnetic wave propagation is that since Maxwell added that term, no experiment in the history of 150 years has ever been shown that an electric current can self-induce a magnetic field. It's like the charge potential has to be there, whatever it is. Like, I don't know, what that means or like how to describe it or whatever, but I'm just saying to ignore that aspect of the phenomenon and just kind of go with what the mainstream interpretation is post Maxwell's reification fallacy.
Actually, I'm going against the mainstream. The mainstream does parrot that phrase of particle wave duality, which is illogical in of itself. Like, you can't be both a wave and particle at the same time.
Agreed.
That's just illogical. Like, not getting into the science of it. Logically speaking, you can't. Like the law of non-contradiction, right?
Yeah,
you can't be both. But
you think what something is, bro. So technically, it's not a wave, but it is something waving. That's why there's got to be an ether, because we define it, measure it, and calculate it all as a wave, and we observe it as a wave. So what is waving?
I mean, no, you observe it as a particle.
My point is waving a thing. So you can't call it a wave, but it's ether. That's what's waving. And so what hit the plate was the charge in the ether, like heat coming from light. It's just energy, a little speck of it.
Yeah, I mean, my understanding of the experiment is that the idea is like the effect that you get from the observer in the experiment is the wave function collapse, right? This is what you get without that's the whole point of that's the interesting part of the fucking experiment. It's insane. It's something that contradicts all fucking like ways of thinking the world works. How does an observer change the behavior of light, basically, whether you want to think of it as a particle or a wave?
It's all reification mathematics. In the hypothesis is wave function collapse. So if knowledge, then wave function collapse. So how can so that's saying, so if we have knowledge of which path, then so just saying the wave function is purely mathematical. That's the whole reification that they've when they try to make it a particle,
that's making
an electron, right? They say it hits the plate, the photon releases an electron, so they define it as a particle mathematically. The math ain't in the wave, and a wave ain't what something is, bro. So it ain't a wave hitting the plate. Is anybody talking?
Doesn't sound like it.
I was gonna say that the model is good, man. The model is good, like the way they quantized light to make a photon an amount. You know, that's the first part to simulating it, to programming it, to making meters and all that kind of shit. You know, you got to get the smallest amount they could come up with at the time, a photon. You know, in the smallest detectors, and it's very useful. You know, I'm not gonna simulations or voltmeters or shit like that. You know, but when you step outside of that convention and call it a particle, and you know, that's when you come up with arguments. You know, but if it is a wave, if light is indeed ether, then the light ain't a wave. The light would be the ether. It'd be an excitation in the background medium that's waving, because it is measured with a wavelength, and you know, wave function measures waves, period. But to say that's the reification, no, it's the particle part that's the mathematical reification.
Yeah, and the photon part doesn't fit that either with the ether.
Yeah, but the wave function, as I explained, is a probability distribution. It's not an actual wave. It's a probability distribution. It's a mathematical function. It's based on probability.
Wave. It's how they measure waves. You got wave function and you got wave equation. Okay, they both measure waves. To say it's just math is not honest.
No, but I'm explaining what the wave is. It's the probability distribution. It's the probability where that chunk of light is going to end up on that plate. That's all it is. It's a probability function.
I agree if you break the wave down. But here's the thing. Is it fair? Is it accurate to put mathematics in the hypothesis? So that's the dependent variable is wave function collapse. Or that's the if A, then B, like if knowledge of which path, then wave function collapse. Okay, is that accurate to put that as the variable in the hypothesis, or is that pseudoscience?
Well, what is wave function? That's the whole point. It's mathematically described as a wave, right? But what actually is it? It's the probability where that. See, the idea is that when you shoot that discrete part of light, which slit is it going to go through? You don't know, right?
Yeah, you do.
Do you? Without observing it? You don't know.
What causes diffraction, bro? Interference. If it interferes with anything, then it's gonna wind up wherever. It's gonna, and yeah, we can mathematically predict that. If it goes clean straight through.
Exactly. That's what a wave function is.
If we've got a detector, we know clean straight through, then it didn't interfere with anything, and it just left the two lines. Just common sense, dude, that people overlook. That's the
my whole point. How does an observer change that behavior?
Doesn't.
But
it interacts with it. It interacts with it. Listen, what you're arguing against is the fact that a photon or any quantum particle, when it's not, when the wave function hasn't collapsed, it will collide with its own wave function, meaning that it will go through both slits and it will have a interference pattern. And this principle is what allows quantum computers to even function. So it's definitely a real phenomena. You can't just deny that it happens.
Exactly.
I'm just saying, in the freaking hypothesis is wave function. That's math. That makes it pseudoscience. It's not if your hypothesis is if knowledge or whatever or observe, then wave function collapse. That's your hypothesis. You're trying to prove. You're trying to
wave function is just a pattern. It's
in other words,
that's all it is.
You just did just
you're explaining it No, you're explaining something mathematically. That's
not mathematics. Now
the phenomenon exists, but you can explain it.
Now you're saying it's not just mathematics, then, right? As you claimed earlier, it was just mathematics.
To reify the mathematics, which it calls it a wave or expresses it mathematically as a wave, to reify that into a physical wave, that's what I'm calling a reification. As opposed to the other way around, you're calling to call it a particle to reify it. But I failed to understand reify what into a particle.
No, I'm with you on that. It's not just mathematics. When you say wave function collapse, it's not just mathematics. I was making a point, and yeah, you agree with me. Wave function is not just mathematics. It's how they measure waves, wavelengths, and oscillations.
In this instance, it's expressing a probability distribution. That's the mathematical function.
Yeah,
that's what I'm
we
saying.
know what causes diffraction. We could mathematically, get probabilities. Like I said, all that shit's useful. It's a convention. It's useful. I'm not denying all that. We get the probability of where it's going to hit when it's interfered with, or when it hits something, the edge of something, or itself. We know what causes diffraction, interference with itself, with the slits.
Yeah, but that's kind of the issue, is that if it's interfering with itself, that means that the wave function that is currently describing its superposition is actually that superposition is not just a convention. It's actually something that's happening because it's interfering with itself.
Well, that's the difference between coherent and incoherent light. Like down to a small, teeny bit, you could get it where you interaction with itself, but it's still got to, to not go straight through. It's got to interfere with something. So they're trying to reify, like, look, coherent light. Is there even any coherent light in nature, like laser beam?
Sure, but you understand. You can get this effect from buckyball, which is the size of 64 carbon atoms. So it's fairly big compared to a photon, and you can get the same effect.
It's a charge, yeah. Buckyball is what? Show me
With
that.
a single buckyball. With a single buckyball, you can get it to interfere with itself.
Can you show me that? Can you show me any of this shit?
Sure, hold on.
I think it's all set up, and I think the cause is in the experiment. I think it's pseudoscience. I think it's a useful convention. Nothing more, nothing less. If you want to try and claim light's a particle because it hits a plate and you want to claim it releases an electron and call an electron a particle, sure. Good
but
convention.
A buckyball only has 60 sides because it's 12 pentagonal faces.
You said 60? Yeah, 60. Okay.
I believe so.
I say 64.
Next.
But if the ether is the water, so the ether is not, the light is the water. So if you squirt a small enough dot where it doesn't get interfered with, okay, you could say it's interfering with itself, this teeny little dot swirling around, measure, whatever. But if it's small enough to make it through just one slit, then we know right which way it's going to go. So if you say you have a detector to claim it went through that slit, then it went clean through. We know that, and it's just going to make a line, small dots of water. So that doesn't make water not having waves. It can move around with waves. I mean, that's how basically the motion of water works. I'm not saying that you can't interfere with it or use different amounts of it and shit, but it's still a better way it's a better convention to me to describe it like the light as the water itself, and it waves. Doesn't make the light an actual wave because there's no such thing really as an actual wave. A wave is what something does, not what something is. So I hate arguing whether it's a wave or not because we quickly lose sight of that in the middle of the argument.
Well, here's something slightly bigger than a buckyball that's been shown to have superposition and will interfere with itself in the double slit experiment.
Yeah, so shit small is wavy, like is elastic almost, for lack of better terms. Shit on the small scale is flexible. What would you call it?
I don't know.
So light is not a wave. Light waves? Is that what you're saying? Because
yeah, technically light is what's happening. It's interference in the ether.
Yes.
Light
yes,
is the ether.
I can't believe there's so many discussions, and all it is it's the light that waves. Light isn't a wave. Okay, thank you. Wow, good summation.
what is light if it waves? What is it?
It's a freaking disturbance in the ether. Basically, if you excite the ether, which is basically just a potential, right? God, it's so hard to explain. But if you excite that with differential, then it basically lights shit up. So you have different modes of that. You have different spectrums of light, depending on how much excitement you added and how you focused it or whatever. I mean, there's better people at explaining this than me, to be honest. This is the way I understand them to say it.
I've heard it from the best, but I always feel like I'm trying to get to something to hold on to, like something observable, or like okay, light waves. What is light? Excitement of the ether. What is ether? A medium made of what? You know what I mean?
Quantum field. So
Ether is quantum
electron field. Well, the ether is describing the same things the quantum field is described, but the light's propagating through the quantum field. Yeah. This is what it's behaving like a wave. The wave is the propagation of the energy through the quantum field. Right? Typically, the electron field. The electron field and the photon field interact.
Man, I booted myself somehow. I didn't catch the last question, but I'd say this though: the reason that I'm on board with hearing all about the ether and considering it is because ether means no globe, basically. No. I mean, if you could prove the ether, then the globe model crumbles like one step at a time into oblivion. That's their excuse for every experiment they did was claiming it's some ether bullshit test or something, you know.
You understand the ether, as you know, championed by Dirac, is no different than the quantum fields, and the quantum fields don't do away with the globe, right? They're not. I don't understand why you're saying that.
Crocio, in physics, what paper abolished the ether, like thoroughly? What paper, what theory, or whatever you want to call it? Who wrote that? Who did away with that? Right. So Einstein. So we get a lot of arguments.
I didn't say any. Don't ask, if you're going to answer your own questions, just don't ask them. Just keep going.
Sorry, I thought you said Einstein. I'm very sorry.
I didn't. But yes, keep going.
No, is that correct? Ain't it special relativity that did away with ether?
No. Okay, I would say that.
Elaborate, please.
I'm saying that you know, there's plenty of tests that didn't show the ether, and so Einstein, you know, sort of showed in several, not even just with relativity, but even with photoelectric effect and stuff like that, and then quantum mechanics, these whole things, they showed why the idea, the postulation of the ether in the first place isn't necessary. It's not that it's just the whole idea that light needing this thing to propagate through isn't necessary. What Einstein did was show that everything's relative, and so there was a postulation that ether was a universal frame, and so through relativity it shows there isn't a universal frame. But as far as the thing that light propagates through, the quantum fields satisfy that. So it's just that there's other things that satisfy what people thought was required by the ether.
I was to the understanding that special relativity did away with her. So I guess I have to go back and have a million different conversations with FTFE, Tune, all these other people, because I believe for them, I'll look into it myself. Ultimately, I was under the impression that special relativity did away with ether. Am I wrong?
It did, 100%.
Well, no, it just satisfied the same thing the ether. It satisfied what the ether, what the problem with the Michelson-Morley was. But the only thing that it did, as far as with the ether goes, is it showed that there isn't a universal frame. So there's because there's not a universal frame, which was like the main postulation of what the ether was. So
that's one interpretation of it. It also showed that the Earth has no orbital velocity, as linear motion and circular motion contribute to a fringe pattern, showing that actually to the first order too. Actually, right? So it's actually a first order dependence on velocity, angular or linear, for the variance in the speed of light. So if the Earth were truly in motion, it would reflect it in the interferometry experiments that you're describing, which relativity was explicitly invented or put forward to explain the lack of motion within that relative framework.
Well, right? No, it wasn't. It was put forward to explain the movement of the electric and magnetic field in relationship to each other, and it just happened to satisfy the issue that happened in Michelson-Morley. But the issue is actually, if you're talking about in special relativity specifically, I think it was even named like the dynamics of moving electric field.
Do you want to see where he got all that? I'll show you. Can I screen share? Is it okay to go mid presentation or whatever? I'll show you where all he got it from and exactly how you're wrong. If you want, I mean, not to be confrontational or whatever, but like, in a buddy joking kind of cool conversation, if you're interested.
Do you know what
I mean,
special
you don't have to.
relativity?
You don't have to ask. You don't have to ask me permission, man.
Oh, I mean,
Do
I
you
don't
know
know.
what?
Sorry.
Do you even
Go
know
ahead,
what
Ryan.
special relativity replaced, bro? What came
It
before
didn't,
special
it
relativity?
didn't. It didn't replace anything, man. It was a postulation about, like I said, the
Supersede. What did it supersede?
Yeah, it superseded the ether framework. Yeah, it's ether framework through the mechanism of length contraction and time dilation to explain why there is no relative motion shown in the experiment that would have produced a fringe corresponding to the Earth's orbital velocity had it existed. So here we have a paper by Hector Monero where he goes through the historical narrative real quick of these papers that recently came to light from Einstein's early writings in regards to how he came up with the special theory and all that. So I'll just kind of run through it real quick. So Einstein occasionally made the statement that he did not know the results of the Michelson-Morley experiment before 1905, because here there's a lot of interpretations, and he gives conflicting statements later in his career and all that. So I can see why you might think that it was unrelated or whatever, right? It just happened to explain it. It's not the case. It was directly responsible
let
for.
me correct you. I never
ahead.
said it was unrelated. I never said he didn't know about it. Didn't say any of those things. I'm saying that the purpose of the paper was to explain, was to describe the dynamics of a magnet or electric and magnetic field. I'm saying it happens to satisfy the Michelson-Morley problem, but I'm not saying he had no knowledge of it, and he.
No, it doesn't. It doesn't not happen to it. It's like directly related to it. Like it's the core purpose. Like the electromagnetic stuff, he just ripped from Lorentz's work, taking the ether framework that he completely made. The only reason that Lorentz's ether framework didn't work is because Earth's orbital velocity through it wasn't shown. But the way that Einstein, co-opted the framework was just saying that we don't need the ether, and if we add the time axis and contract that, we're good to go.
And that's what he replaced: is Lorentzian, Galilean, Newtonian, all that. I would have accepted any one of them, Coach Show, for you to just say, "Oh, it didn't supersede anything." Like, is
it didn't replace. Why would it have replaced Lorentzian? What are you talking about? It employs Lorentzian contraction. Dude.
Hold on. It made Lorentz's ether theory and framework the preferred mathematical framework to interpret everything. And then so the first postulate of special relativity is that all reference frames are equally valid. And what that is that's a pledge of allegiance to Lorentz symmetry, because the way that you verify all reference frames being equally valid is through the mathematics, through covariant transformations, where the laws of physics are invariant when you transform them using Lorentz's Lorentz transformations. So
all inertial reference frames. Yeah.
Yes.
That's right. That's the first postulation of special relativity. That's right.
Yeah, it's in regards to Lorentz's entire framework.
Yeah, Lorentz came up with the contraction. He didn't have a mechanism for it.
No.
Einstein put the things together, but it's not. No one's saying that Lorentz didn't come up with that and this and that. They just didn't have a reason for it.
No. I know that's kind of like what they tell us, right? But the way that it's been measured and the way that the ether works with the relative velocity shown through interferometry, with the first order dependence of the rotation or linear motion, right? So through all that, the Earth's motion would have to reflect in any ether theory. There's the orbital velocity would have to be measured in that regard. So that's why they have to get rid of it and talk about it in this way that you're kind of talking about it now. It was never measured, and Einstein solved that for them because his contribution to the co-opting of it was adding the time axis. Because if you do that, then you can proportionally contract everything to remove the ether mechanic where you're going to get that expected measured physical fringe shift. And he says, well, there's nothing there except the contraction of space time due to your velocity or whatever, right? So he explained the variance shown without having a mechanism to produce the variance, which reveals the fact that there's no orbital velocity. That's what his contribution really was. That's the obfuscation that's been hidden. That's why it's so. That's why Einstein himself, Brian. That's really
Listen,
hard.
if you guys are going to talk to each other,
yeah,
if you guys are going to talk to each
yeah.
other, that's fine. But if I'm not going to, there's no need to pretend I'm responding if I got no chance to respond. So
yeah.
Fuck,
man.
No, just go ahead. Go ahead.
That's all I wanted to say. Sorry.
Sorry about that, Coach. Continue, man.
No, I can't right now. Hold on.
It's all good, dude.
I'm just trying to simplify it for laymen. Like,
yeah, you did a real good job simplifying it by talking over everyone, man. Thanks.
I'm sorry, Alan, man. I'm very sorry. I just wanted to throw in real quick. I swear I thought you was
I know,
done.
dude. I know you just wanted to do it. I know, man. I got it. Everyone does that shit. I got it. It's all good.
I don't want to get this out though for the life, real quick, Alan, and I'm all ears, bro.
Okay, bro, get it out.
Relativity, and for laymen, special relativity replaces the constant. Before special relativity, ether was essentially the constant. And that's what Alan's saying. I wasn't trying to step on his toes. I swear to God, I thought he was done, dude. Keep getting kicked out. I got a bad connection or something.
Thanks for being a hero, Brian.
Give me 3 minutes.
So what just happened? Brian was interrupting Alan. Alan left, and now Brian left. Way to go, Brian.
Guess they insulted each other right off the live stream. I don't know.
Yeah. I say fuck you, SE.
Hey, what's up, Turnip?
What's up, SE?
Oh boy, I recognize that line.
Who the fuck just said that?
The worst nightmare.
Oh God. Better not be Cookie Monster.
No, I'm not God. Okay. Sorry. I try.
What? I said Cookie Monster, not God. How the fuck did you get those two construed?
You said no. You said God, and then you said Cookie Monster.
Oh God.
See, there you go again.
Shut the fuck up.
Well, you gotta admit, I did make you laugh.
Hey, I should probably warn y'all. As he probably
How
already
often does that
knows.
happen?
But
How often does that happen? Do you get a
I've been
good laugh
drinking.
from somebody that's not insulting you? Well, yeah, okay, that makes it easy. I'll give you that. I'm always usually
I've
giggly
been
when I
drinking.
drink, but when I'm drinking, sounds like you're having fun.
I'm in a better mood tonight, though.
Kosho never answered my question from I think last week. How do you measure the weight of gas, like a free gas, not contained gas? Kosho, how do you measure the weight of gas?
Well, wait a minute. Isn't all gas contained? Like we're contained. Right? Technically, it's all contained somewhere, unless space really exists, right?
Well, Kosho said we put gas in tanks, is what he said, and so that creates pressure. That creates, certain gases turn to liquids and pressure. So then you're weighing the liquid weight plus the tank of that.
Well,
you know what I mean? So
I would
Kosho
say.
said we know the weight of gases. Is what he said. He said we know the weight of gases. Is what he said, and he never answered me last week. I've been timed out for 48 hours.
That doesn't surprise me because I think he does that to a lot of people. Can't help it.
There's no help on the way to gas?
Well, it depends on what are you asking. Yeah, we all understand gas, like when you compress it, that you could then of course you can put more, you can force more gas into a container. Depending on what kind of gas it is, you can force a lot of it. Like let's say propane, you can put like a propane tank, right? If you compress that stuff hard enough, you can put it into the tank, and then it'll actually expand out to be a lot of gas, even though it's only a small amount of liquid, right? So in that case, then yeah, you can compress it, and then it'll start to liquefy, and that's how you can store it. But it only can be compressed to a certain extent, each kind of gas, and it has to be pure and what have you, right? What are we
Obviously,
talking about?
you didn't hear the statement. I made a statement, right? Kosho last week said, "We know the weight of gases. We know this." My question to him was, "How do you know the weight of a free gas? How do you know that?" He goes, "Well, we put it in a tank, right?" Well, that's not the same thing. Okay.
I would advise that you just don't listen to him, but that's just my opinion. I don't, make you think
worried.
bad of somebody that it's on you. I'll let you figure that out.
What do you mean think bad, dude? Don't go too far, dude. I'm not thinking bad about Kosho. Yeah, okay.
Me neither. I'm just saying. I don't know. I would take it with a grain of salt.
About the comments that some of these globers say, like, well, we already know the way to gas. We know that. Okay, so then they start there and they start telling you or somebody all this shit, right? Like, how do you know the way to gas, Kosho?
Yeah, I agree with you.
I don't have a gas scale, right? I can't, like, can pump them. Well, it has to be a container to begin with. So a free gas, right? A free gas is just floating around, like oxygen, argon, radon, freaking nitrogen, helium, everything, hydrogen. They're just floating around. How do you weigh them?
I have no idea. I don't know. I'll just be. I can give you my theory, but that ain't worthless.
Well, Kosho says that he already knows how to weigh them. That's all I'm saying. That's all I'm saying.
My opinion is you probably don't. But who am I to know? Just based on what I've heard him say and the things I've heard him do my habits. There's a lot of other people around you that are smart and know a lot of true, the right information. What kind of show? Bad weather. Yeah. What's up, Andy?
You up?
How you doing, man?
Not much.
I noticed you here. I know you're missing her somewhere nearby, so I thought say hello.
I was falling asleep, dude, to be honest.
And then you heard your name, you're like, what? Wait a minute.
Super late here.
My name?
Oh.
Who is it? Wake up, people. Sometimes I come in here and there's like 4 or 5 people in here and then nobody's talking and I'm like, hello, anybody there? I'm just, nobody here. So I guess fall asleep.
I have an interesting question, right?
Where'd Brian and Alan go?
Throw it out there. Why not? We'll give you a crazy answer.
So sundials,
Go ahead,
right?
face one.
Sundials. Oh, go ahead. Oh, sorry. Go ahead. Thank you, Coach.
Go ahead, face one. I was just curious. Yeah.
No worries, bro. No worries. No worries. I just had a
What about
question, but if
sundials?
you were talking, I'm going to shut up. I'm sorry.
No. The people I was talking to are gone, so just go ahead.
Okay, Coach. So I have an interesting question, right? So we know that sundials are, a thing, right? In history, and like we have, remnants of them, and we can see old ones and all this stuff, right? Would anybody agree with that, or am I just making up history?
Yeah, sundials exist, man. You're right.
Okay, cool. So I just want to ask, where do they exist? Like, have you ever seen a sundial in Ireland or Australia, or like when you go across the latitudes, of globe Earth, right? What do these sundials change shape? Right, just to make sure the shadow puts it, because remember, everything's tilted, everything's rotating, everything's wrong, right? So where do the sundials that we see exist? Right, pretty much at the fucking equator. Right, that's about it. If you can find me a different one, then go ahead. You don't see a sundial in Antarctica, right? You don't see a sundial in Argentina. You don't see a sundial in, let's just say, southern Brazil. You always see sundials right up there in between Capricorn and Cancer, somewhere in there. That's where you see pictures of sundials, right? My point being, the sundials supposedly work in that band right there where the sun is, which, overhead of us. It's not far away and distant and shining on a tilted earth and something spinning. It's always a constant and a reliable source of an overhead light, okay, within that band called Capricorn and Cancer. But out of that, out of 27.4 degrees south or north, right, you don't see sundials because they're not accurate. Coach O, if you're here in Texas, which I think you are, you better batten down the hatches. There's some big shit coming. Coach O, did you have an answer to last week's question of how do we measure the weight of free gases?
Yo, Kosho, you there? Is it hello? Is my headset on?
I'm here. Okay.
Oh, okay, yeah. Was you know where Kosho went?
I don't know.
You know, believe it or not, we don't keep tabs on people.
I'm not his babysitter. I'm not his
We're
babysitter.
not. We're just volunteers. We just show up when we want to, bro. We don't know. I mean, if he lived next door to me, I could tell you, bro. But you know, like,
My bad. He was just here like 5 minutes ago. I didn't know if you guys were
I know
here
he
or
was,
not.
but he took off. I don't know yet. I don't know where he
Oh,
went.
word. I feel
Maybe,
that. Okay.
well, he went out. He maybe went out to do some research or something. Maybe, probably.
Nice.
Hopefully, because Kosho's like one of the only Globers that keeps coming back to Earth Awakenings, right?
I was
The
gonna say,
only
Dave,
one.
you have a question that maybe we can help you the answer with or something. I mean, we can always try that, but I don't know what you were going to talk to him about.
Oh, yeah, we were having a previous interaction and some external circumstances were happening and I got heated and walked away. And I just wanted to apologize and see if he wanted to pick up where we left off on that.
Oh no! I'm just kidding. I was going to say we don't allow that, but I would be kidding.
I just joined in. What
No
were you talking
apologizing.
about with Kosho that you said was heated? Like, what was it?
Oh, it wasn't our conversation that was heated. My buddy Brian was kind of talking over me, and it was also like dogpiling, like in tandem with how I was, having a conversation with Kosho. So it was just annoying as fuck, and I got pissed, yelled at Brian, and then left. So I just went shouldn't, in disproportional reaction to the circumstances, really.
Yep. Gotcha. Yeah, it happens.
Yeah, but it is the best decision sometimes. Just jumping out and moving on. Don't let yourself get to that level. You know what I mean?
Yeah, your mic kind of cut in and out, but like I kind of agree with you.
Brian Leakey he's a wow. Like like how to describe this guy? You know, he's very terrible at social interactions. I'll just say that. Okay, very terrible at social interactions. Now, what he does, and he tries to explain it. It's almost incomprehensible. However, if you look at what Brian does, right, and you watch his videos and stuff, right, I mean, it makes sense, right? There is a logic behind it, but man, the man himself is so not sociable at all.
Dude, the method to the madness or whatever, right?
Yeah.
But yeah, I think he said he was lagging too, so that didn't help, like in terms of like talking over each other. So
Yeah. It's almost like you can't blame him, but you can. You're like,
yeah,
fuck up,
exactly.
dude. Shut the fuck up.
Can't blame him, but you kind of can sometimes. Yeah, no, I feel that.
And all he's trying to do is contribute, and make, give some information, but he's lagging. He's over talking. He's clipping you off. He's clipping everybody off. It gets bad because you can't. The listener like me can't, like, who's who, what's going on. You know what I mean? So, but I know it's Brian actually, so I expect this. But let's just say an average listener or a new listener is just like, what the heck is going on over here? No. So SpaceX just launched out of I guess Houston, like way more Starlinks. Are we believing that? Are we not doing that? Or what are we doing?
What's the download speed on Starlink? Has anyone used it? What kind of service does it offer?
I don't use it at all. Well, not that I don't use it at all. What I mean is, I listen. The only thing I have seen from Starlink, and I'm down here in Texas, is one night about 5 months ago, I saw east to west, like 16 dots just going across the sky.
Yeah, I've seen them too.
Like right in a row. And I was just like, I messaged, Travis, Plain Truth.
Yeah, I think so.
Yeah, he's a friend of mine. I called him right away. I was like, dude, look up, see if you can see him. Because, if they're pretty that high, like maybe. Anyways, he couldn't see him. But my dog started barking at him. Even my dog saw him. It's like, woo, 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 just barking. And, but that's the only thing I've seen of what they call Starlink. Right.
Yeah, same. I've seen a similar uniform configuration going across the sky.
Yeah.
But yeah, in terms of like what they launch and like what's actually there and the service they provide, like, who knows, right?
I haven't heard anything about it, like it's so great or anything. You know what I mean?
Yeah, I don't know anyone that actually
Like it's better than our
uses
land-based.
it.
Sorry, go ahead.
Starlink. Let me see a Starlink review on YouTube. Starlink review. There's got to be someone that uses it, right?
Yeah.
Honest Starlink review. Okay, here we go. Yeah, have you ever used satellite internet?
Me?
Before? Like what they call satellite internet? Like actual satellite internet, what they say?
No, I have not.
Oh, dude, it's horrific, bro. It's the worst. It's like unusable, worse than dial-up, complete like incomprehensible, like just terrible speeds. So yeah, it'll be interesting if like Starlink provides like a usable service, because then that would imply it's obviously way closer than whatever they say. Yeah. So
yeah,
where's the speed test at for these people? Like, I'm not trying to watch a 20-minute video of this woman talking about it. Like, just show me the speed test. Oh, there we go. Yeah, check this out, dog. Check this out. This is what she's saying. This is what she's saying her Starlink speeds are.
What is their coverage versus the current towers that we have today and cables we have? They should be flying over less. What's the word I'm looking for? The people that don't have internet. About that. And why would those people need internet when they don't have phones? They don't have computers. They don't have like all this stuff. Like what?
Oh, you're talking about the balloon programs when they were trying to offer Wi-Fi and stuff to.
Say again. You're cutting out, or I'm cutting out. Maybe I'm cutting out. I was just talking about Starlink wanted to give internet to the whole continent of Africa, let's say, right? just and drop computers and drop phones, and so these people that don't really need them could actually be on the internet, right? I thought that was Starlink's idea right there. Along with Microsoft and Facebook and, just trying to get market share, all the people.
Yeah, it's given. I'm looking at these YouTubers that are like giving their review, or if you're able to hear me, I'm looking at their speed results, and they're all like similar to what 4G speeds would be. So I used 4G for a long time as my primary source of internet. So like I'm very familiar with its speed and serviceability and how it fluctuates, and like like the speeds that they're getting are not consistent with the any satellite stuff. But I don't really know like what they might have a different explanation for how they say their satellites work or something. But it looks just offhand. It looks pretty close to LTE.
Yeah, across the board, you could just say that no, it's not delivering anything beneficial to, let's just say, a Starlink subscriber, right? Where where you could just go to your local subscriber.
No, there's places where you can go. That's what it offers though. Like but see, here's the thing. They started doing the same thing with LTE like years ago. And like I was saying, when the LTE network hit the phone towers, I was able to just use my cell phone as my primary internet source for like 5 or 6 years. Actually, a little longer than that.
Yeah.
So, and the speeds that they're getting are like literally the same kind of speeds and ping that I was getting. So, like, yeah, the idea that this is a satellite service is just, it's not really on the table, in my opinion. But again, I don't know that much.
Yeah, with Starlink, right? We're comparing Starlink. Are we comparing Starlink with the system we have on land? Right?
Yeah, because I used to live in an area where there wasn't like ground cables laid, so I couldn't have like, the best I could get was dial up. But then they put the 4G networks up, and then boom, I had it on my phone, and that was a wrap. And then all of a sudden,
Yeah. And that system, to this day, I do believe is still the only system that is really feasible, the one that exists. There's also TV networks that say, "Oh, we're Dish Network" or something, but it's not like, I don't have it, but my neighbor does, and he's like, "Dude, it keeps cutting out. We're canceling this Dish Network. It's fucking stupid."
Yep.
I'm like, well,
Yeah, man. Like back in the day, so what they like, all the phone companies, right? Like Sprint, AT&T, T-Mobile, Verizon, they would all say that they were offering unlimited LTE or 3G, speeds or whatever. But what was actually happening is when you would hit like 20 gigabytes, they would start throttling you to even below 3G speeds. And Sprint was the only company that actually was unlimited. And I used them for years. Like I was downloading like at least a terabyte a month off of that. It's crazy.
Yeah.
But yeah, they all had the same package. They all had the same price, and they all had the same story. They had this illusion of like variability, like where you could pick a different company and get a different package with unlimited, but none of them were actually unlimited. Because I tried some of them and they weren't, even though they said they were. They all had like little disclaimers. It was crazy. It was a crazy time. Just some like
at that time, right, none of them were claiming that we have satellites in space to provide you with this, better deal or better speed, better bandwidth, better LTE, whatever, right? None of them, they didn't claim that. They just said, "Hey, subscribe with us." Okay.
Yep. It's on our LTE network. Like they show you that LTE map or whatever and all that. Yeah, they don't claim any satellite support from it. And then all of a sudden, homie shows up with a quote unquote satellite network that matches LTE speeds. Very nice. Like they just got everybody. Like, hilarious.
Yeah, the idea of hey, pay a little extra, you're gonna get a satellite service, right? And all these people did around the world or across the world, right? We're just like, yay, just looking for service of, hey, we want all the channels. We want to watch all this fucking bullshit on every single fucking stupid channel you can ever fucking imagine. And they get at first they did, but then it was like, no. Now, okay, unavailable. Like, what the fuck is going on, right? You quit,
Yeah, GG. There it is, right there. They're 28 milliseconds. That shit ain't in space.
Exactly.
Do a ping test on satellite internet, dog. Like, yeah.
What's a ping test? Ping test to the moon, wasn't it like almost 3 or 4 seconds to the moon, right? Something like that. I don't know. Don't quote me on that, but Coach Oak probably fucking correct me. But yeah, if you're just if you're a satellite up there somewhere, like at the cloud layer, basically not even breaking the the surface of the earth, pretty much. A ping test should be like milliseconds.
We should at least be in the hundreds of milliseconds, right? Like at least,
sorry.
you should at least be like a full second.
Microsecond. Yeah. Well, you know what I mean? Like it should be quick as fuck because that's how you get all the data transferred, you know what I mean, to my TV, And if it was a millisecond, I'm sorry. That would be too much lag. Yeah, it'd be way too much lag.
No, it'd be too quick. You would be looking at like at least over a second in delay. So your ping would at least be 1 full second, like minimum, on satellite. It's horrible.
Oh yeah. Okay, I'm sorry. I was going the wrong way. I was thinking about from my I was thinking about the ground-based system. I'm sorry. Yes, from a something that could be up there trying to give me data back to my quote unquote dish that goes to my TV. Blah blah. Yeah, and you say it's over almost a second.
Yeah, I used to play RuneScape on satellite internet, and the latency was like, anywhere from 1 to 2 seconds, like minimum. It was atrocious. It made it completely unplayable. Dial up was better.
Yeah. Dial up was better.
Dial up was literally like significant, like by a margin where the game was actually unplayable because you at least need to react within a second on that and on that game, and yeah, you literally couldn't do it. Like it would like your clicks would be delayed. You could lose clicks. Like it was so bad.
So you found on the Starlink that you called it latency because I'm not I have no idea what the terms are. What you're calling latency, meaning time lag from point to point, maybe. Is that what that is? Latency. Okay.
Yep. How long it takes from when you send the signal from when you get it? Or you send the signal when it comes back, rather. But yeah.
And Starlink is right now like right about hovering at about a half a second. or so.
I don't know what they say their parameters are for their stuff. So,
and where do they sell the Starlink dishes? Like, how do I get a Starlink dish if I want to subscribe to their service?
I think you just Google like Starlink or whatever, and then just go to their website. You order it, and they send it to you. They put you on a list, and they send you the package.
Wow.
Yeah, I was watching here. Here's a video of Wrangle or Star who got it recently. 1 second.
Yeah, I know. Oh, Wrangle Star. He's cool.
Yeah, check this out. So this is like the setup for it. So yeah, dude, you just cop that big antenna, that LTE antenna. Very cool. All right, man. I'm gonna head out of here. You guys have a good night.